Hi guys, I'm Hero Serrano and I develop a game engine. And thank you for joining my Twitch today. I have some stuff that I want to share with you regarding the development of the game engine that I've been developing for the past 6 years now. So, to all of you, you know, joining my channel, thank you. So let me give you some announcements that I have. Number one, I hired a new uh, artist, a graphics designer, to design my new logo and also some of my the Twitch banners and the screens. Um, so hopefully I should have them ready. Well, she should have them ready in by May 15. So in 2 weeks, I should have like a new logo and a new Twitch banner and profile and all of that stuff. So I'm kind of excited for that. Um, Aside from that, I've been working a lot on the engine this whole week. Basically, what I did, if you recall, the week prior, I basically was, testing out some of the steering behaviors outlined in this book. And what I did, I basically was playing around with them, trying to get a feel for them, understanding how they work. Um, and I was able to get them to work properly. What I did this week actually was I took all of that knowledge and I implemented the first few classes of the AI system into the game engine. Um, and that's been working quite well as of now. There are so many other steering behaviors that I have to implement, but I would, implement them, uh, slowly but surely. All right. Aside from that, I want to share something with you. So let me bring this up over here and let me actually talk about some stuff that I want to share regarding game engine development. All right. So if you are new to this whole to game engine development and you want to develop your own game engine, let me tell you this: it is it is very exciting and it's very fun, um, and in my opinion, it will change your life. It has changed my life in so many different ways. For one thing, I can tell you my programming skills they improved. I learned so much about design patterns and algorithms, and obviously about computer graphics, shaders, linear algebra, etc. So many. I've learned so much. Uh, I've also, met amazing people throughout this process. Uh, but there are some things that I want you to be aware of before you start on this exciting um, path of developing a game engine. All right. Um, and I wrote about this on my blog way back in 2015. Um, but I want to share them with you today. All right. So basically, if you go to my blog and you go to articles, um, I'm just showing so you could know how to get to there, and you go to the non-technical articles on game engine development. The fifth article that you see here, which the title is "Four Things to Be Aware of Before Developing a Game Engine." All right. Um, Again, it is very cool to develop a game engine, but there's also the bad side of it. All right. Number one, it is a very very slow process. All right. Um, there is a lot that you have to read. There will be uh, a lot of long nights that you will spend reading books on algorithms and design patterns. And if your C++ is not that great, well, you will have to improve it. If you do not know anything about design patterns, well, you will have to read on that. If you are afraid of algorithms, well, you need to get rid of that fear and start understanding how algorithm works. All right. If you do not know anything about computer graphics, well, you need to read books on it. Read books on OpenGL, shaders, um, and if you didn't like physics in college or high school, well, guess what? You better start loving it now, because when you develop a physics engine, well, um, you need to have a good grasp on on physics and Newtonian mechanics and stuff like that. Believe me, there's a lot of things to do to get to that point when you actually have a game engine ready. Um, it took me about 3 years to actually um, develop the basic architecture of the game engine. Okay, 3 years of a lot of hard work, but by that time actually, I only had a basic framework. Yeah, it was something that I could. It was not something that I could share because it wasn't ready yet. It was like it was simple in the scheme of things. It was very simple. It took me an additional 2 years to actually get um, the whole game engine actually, to the state where I can share it to the whole public, and so people can actually develop games, and I could develop simple games on it. So it is a very, very, very slow process. All right. Number two, like I mentioned, you will have to do a lot of readings. Within the first 3 years, I recall I read about 50 books on computer graphics, OpenGL, physics engine, C++, collision detection systems, computational geometry. I read a lot, believe me, these are just the books that I read. On top of that, I read articles online. So I spent most of my 3 years either in my room reading till late at night, or at Starbucks, reading the whole day. And actually, I have a photo here that I took that shows how many books I had to read to develop the basic framework of the engine. Um, there's a lot of books, believe me. So a lot of reading. Then the third one, and this is the one that actually may kill you psychologically, because there will be not much to show for after all the hard work. All right. Don't be surprised if you spend month and month reading and implementing code just to add a small feature to the engine. All right, expect that to happen. I give an example here about adding shadows into your game engine. The whole concept of how shadows work in a game engine is quite simple. It will take you less than 5 minutes to understand the whole concept, but to get it right, that is a different story. That, expect a month to get it right, to get it properly working. Another good example is a collision detection system. The whole idea of how you can actually determine if two convex objects are colliding is quite simple. It's very simple. The idea is simple. However, to get that to work, you need a ton of peripheral functions, a ton of peripheral code. For example, you need to determine if a point is within a tetrahedron. You need to determine if two triangles are intersecting each other. You need to determine if what are the pericentric coordinates of a point that lies within within a triangle. There's a ton of work just to get the collision detection to work. So it took me like about a year actually to get the collision detection to work, and believe me, throughout that the whole year I was debating if I should either quit game engine development and just move on, or keep at it. Luckily, I kept my focus. I kept at it. I kept working on it. But with all honesty, I wanted to quit almost every single day. I was just tired of it. So this is the part that may actually force you to quit. because it's going to mess you up psychologically. But if you keep at it, believe me, you will have a huge smile in your face. And then the fourth one, believe it or not, it can get a bit expensive. And how? Why? Basically, it's because of the books that you will have to buy. Um, I have bought so many books from Amazon. Books on computer graphics, C++, linear algebra, tons of them. Um, and so expect that you expect to spend money on it. And if you can actually buy used books, go for it. If you can actually ask your library, to order some books for you so you can check them out, do that, because believe me, it is very expensive. The last book that I bought like 2 weeks ago is actually this one, Artificial Intelligence for Games, and this book was about $53 or so, $50. But I also know that the new edition came out, and just so you see, let me go to Amazon. Let's see. Oh, here it is. AI for Games. I was actually checking it out because someone on Twitter sent me a link telling me that the third edition had already come out. The one that I have right now is the second edition. The third edition is actually $85. So I'm not making this up. When you get into game engine development, be aware that you will have to spend a bit of money just to get things working. So those are the four things that I want you to be aware of before you embark in the whole amazing experience of developing a game engine. All right. Aside from that, let's see what I want to talk to you about before we get into the whole artificial intelligence steering behaviors that I've been working on. All right. Yes, I want to show you this. So, I don't know if if you heard about this game, but this game is freaking awesome. All right. The game is called Kitty Baby Star Child, and I'm showing you this game specifically because the developer of this game developed this whole game using a custom-made game engine. He actually developed a game engine and he created this beautiful game. And I want to share it with you. Let me give me a second. Come on. Give me a second, so it's going to replay in a few minutes. Come on, dude. All right, let's see if we can play it. So I want to play you the whole. Oh, come on, dude. I want to show you this game because I want you to see the graphics in this game, which is beautiful. It's amazing. So let me see if I can play it on Chrome. For some reason, it's not playing on. Okay, here it is. All right. So the first time that I learned about this game was actually I saw a tweet. The developer had tweeted the screenshot of his game, and I liked it. And I think that a couple of days later, the developer sent me a DM telling me, "Hey, it's so cool that you're also developing a game engine." He mentioned that he has developed a game engine, and and this and that. And then when he said that, I'm like, "Hold on, did you actually develop this game on a custom-made game engine developed by you?" And he said yes, and I was like amazed. I'm like, if you look at this game, it's freaking beautiful. Like, look at the graphics. So I was just amazed, and to know that someone out there also developed a game engine, is developed and has developed this beautiful game. So if you want to check it out, go on Steam. The game is called Kitty Baby Star Child. Yeah, I have to say that the graphics are just beautiful in this game. So go check it out if you ever if you want to play a game like this. All right. So aside from that, let's get to work. Let me. All right. So let me show you what I've done the whole week. All right. So number one. All right. What I did the whole week was basically I implemented the steering behaviors for the AI system, and you can see them here. I implemented various behaviors such as seek, flee, arrive, pursuit, etc., etc. And the whole architecture, how I implemented them was like basically I created a class. It's called the steering, and this class has one important function called get steering. It's a virtual function, and from this class, the other behaviors basically the other behaviors inherit from the steering behavior. So this is the parent class, and these are basically the children classes. So I have seek, arrive, and flee. And you can actually see that seek here is actually inherits its behaviors from steering. The main function that I implement is basically get steering. And if you remember from last week, I showed you how the whole steering works. I'm not going to explain that right now, but basically, you know, I implement the whole steering behaviors in this class. Same thing for flee and same thing for arrive. All of these classes, they inherit from the parent class's steering. Now, the other classes that I also implemented are pursuit, wander, and follow path. Now, these classes, they inherit their behaviors from seek. All right. And the reason being is that these classes right here, what they do is basically they predict a target position, and instead of me duplicating code, right, I just get that target position and I send it to the parent class, which would be seek here, right? So for example, let me bring up pursuit, right? I get a target position, my predicted position, and then what I do, I call my parent class U46 get steering and provide those particular parameters. I provide the parameter of the current 3D model, in this case my character, and then the target position. I do the same thing for wander. I calculate a target position, and then I give those parameters to my parent class U46, and provide that into my get steering function. And I also do the same thing with follow a path, and which I'm going to be explaining today. All right, how that works. All right, so that's what I did this week. But I also, what I worked on was actually implementing a new steering behavior, which is called path follow. All right, and basically this is the behavior that allows the characters to follow a particular path. Basically, it predicts a position, and then it determines where it should go depending on the particular path that it is outlined. All right. So before I go into how this whole thing works, let me bring up Blender. This Blender here. All right. So here I have my two characters. Okay, this character, which is the one that will be doing the whole uh, 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 path follow, and this character which will be just standing there, he will not do anything there. All right, so what I do here is I actually created a path, right? Um, and basically this path is right on top of the black um, path that I did, just so for visualization. But basically the character will be following the segments that you see here. It will follow these whole segments all around, and he will go around the whole thing, coming, do the whole circle on and on. And the character itself doesn't follow the path, precisely. You don't want to do that. You want him to be able to move around, and that is um, the whole reason of why you have a path with a particular width, right? For example, the width of this path is like around about 0.5. This is the center line that he needs to focus on, but then you also want to give the character like some kind of a leeway so he can move around within that path. You don't, so he can actually, so that the whole movement is not too robotics, but he will be able to just wander around within that path, and that's what you do here. And before I explain to you how that works, let me show you the whole how he moves. So let me turn on my this and I'm going to run it. All right. So it built successfully. All right, so now let me change to my Mac so you can actually see it. It should be coming up in a few seconds. All right, there it is. Right, so now I'm just going to tell the characters to start following the path. And as you can see, he wanders around within within the width of the road, of the path. He just goes around the whole path, and following the particular segments. Right now he actually turned back, and I will show you why he turned back. There's a reason why. He shouldn't have done that, but I do know why he did that. So now the character will be able to move all around the whole path and going in circles. Obviously, you can come up with your own path and do whatever path you want to do. So let me stop it, and let me explain to you how it works. All right. So keep in mind this whole path. All right, these segments that the character is following. All right, because that's going to be important. All right. So to implement the path follow, it actually works like this. Number one, you need to provide a segment, right? Which is this one that I'm highlighting right now. All right. And then you also need to provide a path width, right? And there's a reason why you want to do that. So the first thing that you do is you compute a predicted position for your character. All right. So this is my main character, and I want to predict a position. All right. And how do you predict that? Well, you basically get the current position of your character, and then you add that position to the velocity and then you time it with the current time parameter. And that's going to give you a predicted position, which I show here. So predicted position is actually the current position of the character plus velocity times the time parameter, which you have to state. All right, so that's going to give you this predicted position. All right, now if this point is outside of the path width, then you must do the following. You must compute the closest point to the path. Okay, so you get this point and you must determine, all right, what is the closest point to my path? And in this case would be a point something as it will be how would you say that? Oh my gosh, my mind just went blank. It will basically be a segment perpendicular to your path, right? And that segment will give you this point. All right, so this will be your closest point to the path. All right, so once you have that point, you must provide an offset. You provide how many units you want for that offset. So then you provide this offset, which must be along the same direction of the segment, obviously, right? So then this offset will move this position, this point, to a particular location, right? And this will be your target position. Okay, this will be your target position. So basically you will force your character, instead of moving that way, he will start moving some kind of this way, moving towards this particular point, right? And then you get this target position and you send that to the seek behavior, right? And that will basically make the whole motion that for the characters to steer towards this position. And that is how it works. That's the basics of it. All right, so now what happens if your predicted position is actually within your path? Well, you do nothing, right? Here in scenario 2, if my predicted position is within my path width, you basically send this predicted position to the seek behavior and you just let it go. You do this because you want your character to be able to wander around, so that everything looks a lot more smoother and a lot more believable. You don't want your characters to follow this path, to strictly follow that path, because it's not gonna look real. So basically that's how the whole path follow algorithm works. You predict a point, a position. If that position is beyond, outside the path width, you compute a normal point to the segment. Once you have the closest point to the path, to this path, you add an offset, which is along the same direction of your segment, of your path, basically. And then you add that offset, and that will be your target position, and this will be what you send to the parent class called seek behavior. And scenario number 2, if the predicted position is within the path, then you basically do nothing and you just send that to the seek behavior. So let me show you how I implemented that into the engine. Where are you at? So here it is. Get predicted future position. I get my position. Then I get that normal point closest to the path. And basically then I just add that point, I add the offset, and I send that predicted position to my parent class, which is used for this seek get steering. All right, now this will work. What I show you basically not only works for one segment, right? It will work for multiple segments. Like for example, here I have about I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 segments. Um, uh, how I have it right now, um, what I do is I determine uh, the distance between my predicted position and the closest segment to that predicted position, and I use that segment as my main segment. Um, and although I don't like it how I have it implemented right now, what I do, I add all of these segments into a vector, and I basically do a brute search. Where is that? Here it is. Uh, I search all of my segments within my vector container, and I determine which segment is closest to my predicted position. And once I have that segment, well, I make that segment uh, my the main segment to work on. Obviously, I'm thinking of changing that because eventually I'm, I want to have multiple paths, and I can have I don't want it to be a bottleneck where I do a search on vectors, right? I search on a vector container, which is quite slow. So that's basically what I did. Now, what I have planned to do later on is to make this more automatic. All right. What I have right now, I basically I did this all by hand, right? I came in, I opened up Blender, I basically created my own path by hand, and provided this data literally by hand, and I want you to see how I did that, which is horrible. I basically just added the segments, all right? But why did I do that? Well, basically because number one, my goal right now is to get the path follow algorithm to work, right? Later on, what I'm going to do, I'm going to go and write a script that basically will get the particular path that I have, and will be able to read that automatically, export that path to the engine, and then the engine should read the whole the vertices of this path automatically and apply that to the algorithm. I like to do game engine development, little step at a time. I don't want it to I do not like to go full blown into the development. I like to make sure that things are working, the basics are working first, and then I slowly keep adding more features and making making the engine more user friendly and stuff like that. But for now, I'm just gonna leave it like that. My goals that I have next is to implement steering behaviors such as preventing two characters from colliding each other when they're walking around, preventing a character from hitting a wall, stuff like that. And luckily, most of those implementations are found in the book that I bought of artificial intelligence for games. So I'm gonna keep reading that book and try to implement as many behaviors as I possibly can, and that I think would be useful to have in the engine. And that's about it, guys. That's all what I have. I wanted to just show you how the whole path follow works. I wanted to share what I learned. As you can see, it's not very hard to implement. It's quite simple. It's quite cool to get it working. And that's all what I have for you guys. So thank you for joining my Twitch channel today. I'll see you next Sunday. Take care.